Hello friends, I'm JYOTHSNA. So today I would like to discuss about carbon and its compounds. Okay, in our daily life, carbon plays an important role day-to-day life. For example, toothpaste, soaps, next cosmetics, paper industry, cloths. So even a bread also having a carbon. So that's why import plays an important role. But still, Earth crust having 0.02% of carbon, and next and carbon dioxide percentage 0.03% only. So this is in case of minerals like carbonates and hydrocarbons like this. Next, coal and petroleum. And the next one, so this is about the occurrence of the carbon. And the next one important role is ionic compounds and carbon compounds, the differences. Just I think ionic compounds and carbon compounds. So ionic compounds, it is good conductor of electricity. Good conductor. This is poor conductor of electricity. This one good conductor of electricity. This is poor conductor of electricity. And next, the melting point, it have high melting and boiling points. It have low melting and boiling points. Okay. And next one, the intermolecular force of attraction is very strong in ionic compounds and not very strong in carbon compounds. Okay, so here comparison, for example NaCl, if you take, this boiling point is 1413 degrees centigrade, and here for example if you take methane, its boiling point is 311, like this. So very low melting and boiling points, it have high melting and boiling points. Okay, so this is a comparison of ionic compounds and carbon compounds. And next one, carbon. If you take carbon, so carbon atomic number is what? 6. So how can we write 1s2, 2s2 and 2p2? So once we can observe the structure of the carbon. So this is the nucleus, the first shell and 2. So how many shells are involved? 2 shells are involved. What is the valency? Electrons 4. So valence electrons 4. Okay. So here like this. So the valence electrons 4. So carbon actually if gain or electrons, so loss of 4 electrons, so it having, for example carbon gain 4 electrons, it have 6 plus 4, how many electrons? 10 electrons. It is very hard, okay, 10 electrons. So next, for example last 4 electrons, so see 4 plus means 6 and minus 4, so 2 electrons. So this is not possible in the as a ionic nature. So that's why carbon can participate in the covalent bond only. Okay. Okay. For example, so carbon compounds, most of them in non-metals, for example H2, N2, O2, these structures we can observe. First of all, H2 molecule, how the covalent bond is observed. H2 molecule, hydrogen atomic number is 1. How can we write 1s1? So hydrogen gives 1 electron, another hydrogen gives 1 electron. So 2 can both sharing. So hydrogen single bond, hydrogen is found. Okay. Next, if you take oxygen atomic number is 8. How can we write the electronic configuration? 1s2, 2s2, 2p4. Okay, so 1s2 2p4, the last shell. So the how many valence electrons it have? 6 valence electrons. Okay, so one oxygen is involved in this one, gives 2 electrons. The another oxygen gives 2 electrons. The sharing of 2 electrons, sharing of 2 electrons, both can share. So it can be participate. So oxygen having double bond. So oxygen sharing 2 electrons, one oxygen sharing 2 electrons, both are sharing of electrons. It having 2 bonds are formed. And next we can take the another one example, N2 molecule. So N2 molecule, if you take nitrogen atomic number is 7, how can we write 1s2 2s2 2p3? So how many valence electrons? 5. But so lone pair is there and it can participate most of the compounds, so 3 bonds only. For example, so nitrogen valence electrons, so 5. So 1, 2, 3, 4, 5. So another nitrogen gives having 2, 1, 2, 3. So like this only you can write. So these 3 electrons can be participate in the bond formation. Nitrogen having triple bond. So that's why they calling the bond order is 3 for nitrogen, bond order is 2 for oxygen, bond order is 1 for hydrogen. Like this, the structures are like this. According to the electronic configuration, the bonds shared electrons depending on the shared pair of electrons, it is possible. Okay. Versatile nature of carbon. Okay, so versatile nature of carbon is first of all catenation property. Okay, so catenation. So catenation property means the self-linking chains. So the large molecule, it forms a large molecule. For example, so like this. So many carbons are formed with linked chains. Okay, so that is same carbon, self-linking. So actually carbon and hydrogen both are combined to form that hydrocarbons are formed. Hydrocarbons are formed. Next, so this is the catenation property. And the next one, valency. What is valency? Valency about to carbon always bond the combining capacity of an atom. So the carbon combining capacity 4. So that's why always carbon, for example, methane. So CH4. So the combining capacity is 4. So the best example, methane. Okay. The next. Okay, now saturated and unsaturated hydrocarbons. So in the catenation property, so the carbon chains are formed. For example, the carbon chains are formed it having only single bond. So that is called saturated compounds. It having double bonds, 2 or more, and next triple bonds, 1 or more. So in this same compound, so that is called unsaturated hydrocarbons. Okay. So any compound if you take all having single bonds, so that is saturated hydrocarbon. And next unsaturated, if the compound having a single bond. Okay, next that is called unsaturated. Triple bond also called unsaturated. And so it having okay. So for example, best example. This is butane. Okay, so CH3, CH2, CH2, CH3. Butane. It having all single bonds. So this is saturated hydrocarbon. Okay. In case of instead of this one, the double bond can be formed like this. Okay. So all carbon having 4 only the valency. So the combining capacity 4 only. So this is butene. That name is butene. Okay. So that name is butene. So like this. Okay, so this is unsaturated hydrocarbon having a double bond. Okay, next. So unsaturated triple bond also having also called as a unsaturated hydrocarbon. So it have a triple bond. Okay, it have a triple bond. So that is called unsaturated hydrocarbon. Okay, like this. Okay, this is called. This is also. Okay. So this is butane. That name is butane. Okay. Structure also changed. Okay. So this is about saturated and okay. Allotropes of carbon. It having different physical states and same chemical properties. So that is called allotropes of carbons. So it having mainly diamine, graphite, and Buckminster fullerenes. These three mainly. So diamond is the hard substance and next it is linked with 4 carbon atoms and 3-dimensional structure. And graphite, it is a three carbon atoms can be joined together. So it is a graphite. And Buckminster fullerenes, it having 6 hexagonal and next pentagonal structures also. Okay, these structures we will observe now. So the diamond structure we can observe like this. So the 4 carbon atoms combine to form like this. Okay, this is the diamond structures and diamond is used for drilling and for next one and used as a jewelry. And next graphite, if you observe, so 3 carbon atoms so like this. So this is the graphite structure and 3 carbon atoms combined to form like this graphite and used as a lubricant and so we used pencil also having a graphite. And the next one Buckminster fullerenes, it having it is a C60 structures like this and all pentagonal structures, all hexagonal structures like this. So it having pentagonal structures and hexagonal structures. Around this one. So like this it happens. So next one functional groups. Functional groups. Actually carbon and hydrogen having, so that is called hydrocarbons, and not only carbon and hydrogen, it having chlorine, bromine and oxygen, sulfur or okay, next nitrogen. So like this, these elements are combined, so that is heteroatoms compounds are is called. And next one is the functional groups. So for example, if you take propane, so this is the propane and one hydrogen, instead of one hydrogen it can be as chloro, Cl group. So that is the functional group. So functional group chlorine is added, so that name is chloropropane. Propane. Okay, like this. Next one. And the next functional groups, So we have functional groups. First one, so chloro or bromo, and the next one aldehyde group, and CHO aldehyde group. Next OH alcohol group. Next this is aldehyde. This is halo. This is alcohol. Next one, sorry. Next one carboxylic acid. And the ketone group. Ketone. So these all are added to the hydrocarbons. So the functional groups are the structure is changed and the name also changed. Okay, for example, chlorine, if you add the that particular compound instead of hydrogen, that is called chloro. Chloro, for example, 3 carbons, propane, chloropropane. Next, for example, added to this one aldehyde and propanaldehyde, the name is propanaldehyde. And for example, OH is added to the last hydrogen, so not only last one hydrogen, so that is alcohol. Next one carboxylic acid, instead of one hydrogen, so the acid is the carboxylic group is added, so that is called propanoic acid, like this. Next one, so ketone is added, propanone, the name is changed as a propanone. Okay. So hydrocarbons. So first one, saturated hydrocarbons and unsaturated hydrocarbons, and the next one aromatic hydrocarbons. So saturated hydrocarbons, so alkanes, okay, alkanes, and the general formula CnH2n plus 2. Unsaturated hydrocarbons, alkenes, CnH2n, and the next unsaturated hydrocarbons, so alkynes, CnH2n minus 2. Aromatic hydrocarbons, so example benzene, CnH2n, C6H6, benzene C6H6, aromatic hydrocarbon. Okay, so saturated alkanes, so alkenes, so alkynes. Okay, only single bond, so that is called alkane, and double bond having, that is compound, that is alkene, and triple bond having the compound, that is called alkyne. Okay, so next, so if you observe the cyclic rings, cyclohexane structure, if you observe cyclohexane, C6H12. So this is a saturated hydrocarbon. This is saturated hydrocarbon. Next, benzene, if you take, that is unsaturated hydrocarbon because it having double bonds. Okay. Next. So alkane, example, methane, ethane. Ethane. So this is ethane, and the next alkene example, ethene. How can we write CH2? So that is, and alkyne. How can we write alkyne? Or this is ethene or ethylene. Ethylene. Next, alkyne or acetylene. Acetylene, C2H2. So these are the examples for alkane, alkene, and alkyne. And next one, homologous series. Actually, this is a the number of, depending on the number of carbons, so the name is changed. For example, CH4 if you take, so this is meth. And for example, 2 carbon atoms are there. This is ethanol. If you take OH group, CH3, CH2, OH, so this name is ethanol. For example, C triple bond and it having OH group is added. So that is, this is propanol. Okay, propanol. And next, so carbon. So how many carbon atoms? 4 carbons. So here 3 carbons, here 2 carbons, here 1 carbon. So that is called a homologous series. Okay, next. Means same functional group is added to the homologous series. For example, methanol, OH, methanol. Okay, next. So ethanol, propanol, okay, butanol. So 4 carbon, 3 carbon, 2 carbon and 1 carbon. So like this. So this is the homologous series. And next one, nomenclature. So first part, nomenclature, first prefix or suffix first. So number of bonds, only single bond, so that is meth. And double bond is added, eth. Next, only triple bond, prop. And 4 bonds, C4, so that is but. And 5 bonds are formed, so that is pent. And 6 bonds, 6 carbon atoms, so that is hex. Hep2, 7 means hep2. Okay, next oct, non. Okay, so 10 is dead. So like this. So next one, nomenclature. Carbon compounds. Mainly depending on 3. What are the first one? The number of carbon atoms in the chain. And the second one, bonding nature, double bond or triple bond. Okay, next bonds. And the next one, functional group, observed on the functional group. So the 3 main we can observe, then only we can easily find out the names. Okay, thank you.